In the previous video, we talked about sample spaces and events. So those two ideas are checked off. We're done. We have two more to go. Set notation used to describe sample spaces and mutually exclusive events. And as I told you, those are going to be much more minor type ideas. So don't worry, this video is going to be much quicker. So first one, when rolling one red die and one green die, consider these events. So what I'm saying here is the event A would represent a red die shows a 1. The event B would represent the numbers add to 4, and so on and so forth. Can you describe the event that the red die shows a 1, and the numbers add to 4 using set notation? So set notation means union, intersect, all the the complements, those kinds of things that we covered in the previous chapters. All right, so give it a shot, and then unpause the video and let's see how you did, because there's nothing new here, just nothing new. All right, so here we go. Pause the video. All right, let's try this. How would I describe the red die showing a 1? Well, that's the event A. Okay, and the numbers add to 4. Okay, the number, oh, that's B. Okay, and then do I need to include C or D? None of this stuff was mentioned, but do I need to put it? Is there any reason why at least one of the numbers is 1? It doesn't mean there's nothing that. Well, yes, actually there is. C is contained in A, but it doesn't bring any more value. A is more restrictive. So A therefore guarantees C, so I don't need to mention it. And then the numbers do not add to 11. Well, I know the numbers add to 4, so I don't need to add D. Those things would be kind of, you'd look at it and say, duh. If it adds to 4, I clearly know it doesn't add to 11, right? So, all right, so I'm good with just A and B. So now, how would I write this using set notation? Is it a union or is it an intersect? Well, if I want it to be both, it doesn't say it can be showing 1 or adding to a 4. It doesn't mean that I can do one or the other and I win the game. And that's kind of an easy way to think about this, is saying if these are the rules to winning a game, say, what do I need to have happen? Well, I need both of these things to have happen. So therefore, I need an intersect. I want the stuff where A is true and B is true. That is the stuff that makes me win. So now, that would be how we'd write it using set notation. Great. So now, let's find the cardinality of this, because that's the second part right here. Then, determine the cardinality of the event. So, and yes, this is done. You're done with that part. This is part A. We are finished. Okay, part B. How do I find the cardinality? I got to count up all of the elements in this subset. I have to count up how many ways there are for this event to occur. And if you're not sure, this is where making those gigantic lists helps. You can kind of just see a pattern, and then sometimes you're kind of done. All right, so we know the red die has to show 1. So what I'm going to do is I'm going to say that as I write these two, I'm going to write the red on the left, and the other one, oh, it's a green die. I was going to make it blue. That would be wrong. So red on the left, green on the right. What are the ways for my red die to be a 1? There's only one way. It's got to be a 1. Okay, then I'm going to pair that up with green. How many different options do I have here if I know they have to add to make 4? Well, there's only one way. That's got to be a 3, right? So therefore, the cardinality would be 1. There's one way for this to happen if I know the red die is a 1 and they have to add to make 4. So there you go. There's the cardinality would be 1. All right. You try this one. Same exact scenario, just a different question. So pause the video, give it a shot. All right, here we go. All right, let's see what it wants. The numbers do not add to 4, but we know they do add to 11. All right, so this is kind of one of those dumb moments like we had in the last problem, right? If we know they add to 11, well, yeah, clearly they don't add to 4. All right, so therefore, out of these, which one do I want to use? Do I need to use that they add to 4? No. I'll use the one that's more prescriptive here and say, whoops, well, I'm going to use the one that talks about the 11. Because I know they do add to 11. This one is that they do not add to 11. So how do I write D? So instead of being do not add to 11, that they do. Well, I would do D complement. Because if I know they do not add to 11, this would make it the double negative. So it's the numbers do not add to 11, which means that they do add to 11. So, Anyway, D complement will take care of that. Okay, and I don't need this add to 4. That was just kind of extra stuff. All right, so now use, oh, and we're done. That's it, right? That's all we need to know is that they add to 11. So hey, there's your answer. Done. All right, now using set notation. Sorry, then determine the cardinality. We already did that. All right, so what is the cardinality of D complement? Well, all I'm really saying is that my numbers have to add to 11. So what would that mean? There's no restriction on color or anything like that. So just I need to think about how many ways are there to get an 11. Well, 5 and a 6, 6 and a 5. Yeah, that's it. That's that. There's nothing else, right? Because if I have a 6, it's got to be a 5. If I have a 5, it's got to be a 6. If I have a 4, there's only 6 sides on a die, so a 4 and a 6 makes 10. That's not enough. So yeah, the best I can ever do is just that. So there you go. 2 different ways. All right. So I hope this helps you get started on those. You'll go into the homework. You'll see there'll be some fun ones in there. Just give them a shot. Um, and I wanted to just show you one more different type of problem. Where I might just give you a table to work from and or another representation. So instead of just giving you something to think about, I might give you some data. And I can still, again, define my 2 events. I've got P for students who pass my class, um, and F who are students who are taking it for the first time. Ha ha ha, not getting an F in the class. Yes, I tricked you. Okay, so P represents students who are taking this MAT217 online for the who have passed it, and then F represents students who are taking it for the first time. Alrighty, here we go. Find the cardinality of P intersect F. Well, what would that mean? P intersect F. That means students who have passed the course, which means I am in this row. I'm looking at these groups of students here. And I want students who have taken it, who are F, who are taking it for the first time. So I'm in this column here. Right? So now the intersect, well, this is kind of simple because it literally is the definition of intersection, how we use it in our life. Where do these things meet? Well, that's at 15. So therefore, there are 15 students who passed my course who took it for the first time in this class of 32. Okay, let's try the next one. P intersect F naught. Well, what would F complement be? What would F naught be? Well, that just means we're scooting over here, saying they're not taking the course for the first time. So therefore, that intersection would be 8. That's not so bad. Okay, here we go. Now things are going to get interesting. We're still using P, right? We're still, in number 9, we're still using P. So cardinality of students who pass the class, union F, not intersect, union. So what would that end up being? That means, what does that mean? It's not. Remember, it's the idea of getting married. You're bringing everybody in these groups together. You're bringing all the stuff from all of his stuff and all of her stuff, and all of it is now your collective stuff, right? So, the union. Now, here's the thing students sometimes get themselves into trouble with. They say, oh, well, I'm going to use these totals. I know the pass is 23, and I know the first time takers is 21. So therefore, hey, that's got to be 44, right? Right? No, not right. Why is that not right? Well, because this group of 15 is in both of those totals. So therefore, you counted them twice. The number of students in the class is 32. There's no way you could have 44 people taking the course for the first time. Anyway, I think you're getting the idea now. I'll stop being dramatic. So there's a little formula that will come up later. It'll make it more formal. But the idea is if you want to use the totals, you absolutely can. You just have to keep track of who you counted twice and subtract them away at the end. Say, I have a group of 23, I have a group of 21, but I counted the 15s twice, so I have to subtract them. And then that will give me my total of, I don't know, let's do some math. Let's see, this would be, what did we just say? 44 minus 15, that'd be 34, 29. 29 students. Another way of looking at this would just be to say, well, who's been highlighted. Not counting the totals, not counting these. We don't care. We're not going to use the totals because those sometimes mess us up. So instead, what we're going to say is just who got highlighted. Well, 15, 8, and 6. So if I add those up, guess what I get? 29. Yeah, it's amazing how that works. Okay. So let's try the next one. Let's try the next one. This one's interesting. I want to zoom in so you can make sure you really see this. I want the union of P and P complement. So what does that mean? I want everybody who passed the course, and I want everybody who didn't pass the course. Well, isn't that everybody? Right? There's no other option. Just you either passed or you didn't pass. Right. So therefore, just logic says that would be, hey, everybody from that first yellow line, that's 23, and everybody from the blue line, that's 9. So therefore, that gives me 32. That's everybody in the course. Yay, we figured that one out. All right. Now the next one, that's the union. Exact same sets, but I want the intersection. I want to know the group of people who passed the course and didn't pass the course in this class simultaneously. If that hurts your brain, that's okay because it's supposed to kind of hurt your brain. How is it possible that somebody in the class passed it and didn't pass it? It's not possible. So therefore, that cardinality is 0. There's nobody. There's nobody who can do that. That's not possible, right? And this is what we call mutually exclusive. Now, just because the number is 0 does not mean it's mutually exclusive. What means it's mutually exclusive is it is something where these two events are not possible to overlap. It's not possible that you can be in both groups. It's the idea that it's not possible to uh, be in both. Okay, and when I say overlap, what I'm kind of saying is imagine you're doing a Venn diagram. You say, here's my group of P people. Here's my group of P not people. Is it possible that there could be some overlap? Well, no. By definition, if you're in P, then you're not in P, or if you're not in P, then you're not in P. You can't be both. If you are 7 feet tall, if you are 7 feet tall, it is not possible for you to simultaneously be 6 feet tall. You're one or the other, right? So those are mutually exclusive events. Alrighty. There's your last buzzword, by the way. Okay, last thing, just going to throw out here because this is going to let us completely skip the next section if you are using the WebAssign book. Do you remember how to do probabilities? I'm sorry, not probabilities. Do you remember how to do percentages? Do you know how to find the percent of something? Well, how do you find a percent? Well, it's part over whole times 100, right? Or whatever version of it you learned in your life. So, what percent of the students are P prime union F? Well, we didn't do that one, so let's do that. So, to be able to answer this question, I need to know the cardinality of P prime union F. I need to know how many people are in that group. All right, so P prime. P prime means what? P prime means that they did not pass. I'm going to keep this highlighter, okay? And then F, taking the course for the first time. That's this group here, okay? Now it's a union, which means I want to keep both. So you can either do I highlighted these 3 numbers, or you could do the totals and subtract the overlap. I'll do the totals. So 21 plus 9 minus the overlap of 6, so that makes 24. So therefore, that's my part. That's my part of the class who meets that requirement. That's my part of the class who either didn't pass or was taking the course for the first time. And it's okay if they pass or didn't pass. It could be either. So now, what is my whole? What is the cardinality of my sample space? Well, my sample space is 32, right? That's how many students are in the class. So therefore, the percent would be 24 divided by 30. this is not happening. 32, there we go, times 100. And we can simplify that. We can get a calculator out. Let's just use our calculator, and we will do that super fast. There we go. So 24 divided by 32. So it's 75. So 75, and then of course times 100 would make 75%. So therefore, you could write this as 75%. Alrighty. Thus concludes this section. So write your summary about what we covered. Make sure you recap the big four ideas, and get all those vocabulary buzzwords, because they are going to come back to haunt you if we use them in a problem and you do not remember mutually exclusive, what it means. Lots of data in there, and it's a really simple idea. You just have to know what the word means, right? Alrighty. Talk to you in the next video.